Welcome back, and in this part of the lesson series we're going to look at layer 2 of the OSI model, which is the data link layer. Now the data link layer is one of the most critical layers in the entire OSI 7-layer model. Everything above this point relies on the device-to-device communication which the data link layer provides. So when you're sending or receiving data to or from the internet, just be aware that the data link layer is supporting the transfer of that data, so it's essential that you understand. Now this is going to be one of the longer parts of this lesson series because layer 2 actually provides a significant amount of functionality. Now before I step through the architecture of layer 2, we have to start with the fundamentals. Layer 2, which is the data link layer, runs over layer 1. So a layer 2 network requires a functional layer 1 network to operate, and that's something which is common throughout the OSI model. Higher layers build on lower layers, adding features and capabilities. A layer 2 network can run on different types of layer 1 network, so copper, fibre, Wi-Fi, and provide the same capabilities. Now there are different layer 2 protocols and standards for different situations, but for now we're going to focus on Ethernet, which is what most local networks use, so things in your office or things in your home. Now layer 2, rather than being focused on physical wavelengths or voltages, introduces the concept of frames, and frames are a format for sending information over a layer 2 network. Layer 2 also introduces a unique hardware address called a MAC address for every device on a network. This hardware address is a hexadecimal address, it's 48 bits long, and it looks like this, so 3E:22:FB and so on. The important thing to understand is that a MAC address generally for physical networking is not software assigned. The address is uniquely attached to a specific piece of hardware. A MAC address is formed of two parts, the OUI, which is the organisationally unique identifier, and this is assigned to companies who manufacture network devices. So each of these companies will have a separate OUI. The second part of a MAC address is then Network Interface Controller, or NIC specific, and this means together the MAC address on a network card should be globally unique. Now layer 2, as I've mentioned, uses layer 1. This means that a layer 2 or Ethernet frame can be transmitted onto the shared physical medium by layer 1. This means that it's converted into voltages, RF or light, it's sent across the medium and then received by other devices also connected to that shared medium. It's important to understand this distinction. Layer 2 provides frames as well as other things which I'll cover soon, and Layer 1 handles the physical transmission and reception onto and from the physical shared medium. So when Layer 1 is transmitting a frame onto the physical medium, Layer 1 doesn't understand the frame. Layer 1 is simply transmitting raw data onto that physical medium. Now a frame, which is the thing that Layer 2 uses for communication, is a container of sorts. It has a few different components. The first part is the preamble and start frame delimiter, and the function of this is to allow devices to know that it's the start of the frame, so they can identify the various parts of that frame. You need to know where the start of a frame is to know where the various parts of that frame start. Next comes the destination and the source MAC addresses. So all devices on a Layer 2 network have a unique MAC address, and a frame can be sent to a specific device on a network by putting its MAC address in the destination field, or you can put all Fs if you want to send the frame to every device on the local network, and this is known as a broadcast. Now the source MAC address field is set to the device address of whatever is transmitting the frame, and this allows it to receive replies. Next is ether type, and this is commonly used to specify which layer 3 protocol is putting its data inside a frame. Just like layer 2 uses layer 1 to move raw bitstream data across the shared physical medium, well, layer 3 uses layer 2 frames for device-to-device communication on a local network. And so when you're receiving a frame at the other side of a communication, you need to know which layer 3 protocol originally put data into that frame. A common example might be IP or the Internet Protocol. So this is what the ether type or ET field is used for. Now these three fields are commonly known as the MAC header. They control the frame destination, they indicate the source and specify its function. After the header is the payload, and this is anywhere from 46 to 1500 bytes in size for standard frames. It contains the data that the frame is sending. The data is generally provided by the layer 3 protocol, and the protocol which is being used, as I just mentioned, is indicated within the ether type or ET field. Now this process is called encapsulation. You have something which layer 3 generates, often this is an IP packet, and this is put inside an Ethernet frame. It's encapsulated in that frame. The frame delivers that data to a different layer 2 destination. On the other side, the frame is analysed and the layer 3 packet is extracted and given back to layer 3 at the destination side. The ether type field is used to determine which layer 3 protocol receives this at the destination. And then finally, at the end of the frame is the frame check sequence, which is used to identify any errors in the frame. It's a simple CRC check. It allows the destination to check if corruption has occurred or not. So that's the frame, and it's an important thing to understand if you are to understand how all of the bits of layer 1, 2 and 3 fit together. So layer 2 frames are generated by the layer 2 software at the source side, they're passed to layer 1, that raw data is transmitted onto the physical medium, it's taken off the physical medium at the destination side, it's passed to its layer 2 software, and that can interpret the frame and pass that on to layer 3, which can then interpret that data. Now, as a reminder, this is the problem that we have with a purely layer 1 network implementation. We have two devices running a game, a laptop on the left and a laptop on the right, and these are connected using a single network cable, a shared physical medium. Now, as I mentioned earlier in this lesson series, layer 1 provides no media access control. The layer 1 software running on a network card will simply transmit any data it receives onto the physical medium. So if the game on the left sends some data, it will be transmitted onto the medium and it will be seen by the device on the right. The problem is that the laptop on the right could also be sending data at the same time. This means that the electrical signals will overlap and interfere with each other, and this is known as a collision, and it impacts both pieces of data. It corrupts both. This is one of the problems of layer 1, which is solved by layer 2, and layer 2 provides controlled access to the physical medium. And let's explore how. Okay, so this is the end of part 1 of this lesson. It was getting a little bit on the long side, and so I wanted to add a break. It's an opportunity just to take a rest or grab a coffee. Part 2 will be continuing immediately from the end of part 1. So go ahead, complete the video, and when you're ready, join me in part 2.